Standing waves and SWR meters. If some of the RF power is reflected at the antenna, then the reflected signal traveling towards the transmitter will mix with the signals going up the feeder towards the antenna and cause an effect called standing waves. The waves traveling up the feeder combine with those reflected down to give the appearance of stationary or standing waves. An SWR standing wave ratio meter can measure the power flowing back down the feeder. Ideally, the length of the antenna would be adjusted to match the wavelength of the transmitted signal, but this may not be possible. An antenna matching unit AMU, see later, is used to provide the best match to the transmitter. If the reading on the SWR meter has unexpectedly increased, it means that more signal power is being reflected back from the antenna. The most likely cause is some damage to the antenna. The cause should be investigated before continuing to transmit. A dipole antenna is a good match only when cut to the correct length. At other lengths, the match will be poorer, depending on how far from the ideal length it is. Figure 6.10 shows the effect of varying the length of two halves of a dipole. When setting up your own antenna, you should aim for an SWR of 1.5 to 1 or better. 1.1 is perfect. An SWR over 2.1 risks damage to the transmitter. Most amateur transmitters do have protection circuits to reduce the power, but they should not be relied on. It is also worth noting that high SWR is not an indication of a fault in the transmitter. The graph of how the SWR of a half-wave dipole for the 2 meter band varies as the length of the arms is varied. In your practical assessment, this has been skipped now, but we'll read it anyway. You'll set up an adjustable dipole, a transmitter, and an SWR meter. The dipole will probably be made using two extendable aerials like those found on small portable broadcast radios. You should be able to find the length for a minimum SWR. Don't forget to give a call sign if your transmission can be heard outside the premises. Antenna matching unit AMU. An AMU is quite common in HF installations where a single antenna often has to be used on several bands due to space limitations. A single antenna will only match well on one band. On other bands it won't match to the feeder, and the feeder won't then properly match to the transmitter. Connecting an AMU between the transmitter output and the feeder will allow the transmitter to see a good match and operate normally as if it was feeding as matched antenna. Without an AMU, the mismatch could be severe enough that the transmitter is damaged. It may have protecting devices to reduce the power, but it is unwise to rely on them. It is normal for convenience to have the AMU beside the transmitter. Any standing waves on the feeder due to the mismatch between the feeder and the antenna will still be there, but the transmitter won't see them. The AMU is often called ATU, antenna tuning unit. It does not actually tune the antenna. That can only be done by cutting it to the correct length. The AMU simply deals with the standing waves and the signal reflected from the antenna so the transmitter can safely deliver RF power. What it cannot do is make an antenna of the wrong length radiate as well as one of the correct length. At VHF and UHF, the smaller size of the antenna allows an antenna for each band of interest, and AMU is not needed. It's figure 6.3, a high power antenna matching unit. Baluns. Look carefully again at the dipole antenna. The dipole is symmetrical. The two halves are the same length. It is called a balanced antenna and requires two signals, one for each half of the dipole. the signals are balanced, and because when the wave on one side is going up, the wave on the other side is going down, rather like a balanced seesaw. A coaxial cable is not electrically symmetrical and is called unbalanced. It has one center live conductor and an earth screen. It is not suitable to directly feed a dipole. A device called a balanced to unbalanced transformer takes the signal on the coaxial cable and converts it to two signals suitable for feeding the dipole as shown in figure 6.11. Insert a balun at the point where a coaxial cable is connected to a dipole antenna. If the coaxial cable is connected directly to a dipole, RF current will flow back down the screen of the cable. This current will radiate and the screening properties of this cable will be upset. Since the cable runs back into the house, radiation will take place inside the house and may cause some interference to televisions or other electronic devices. This must be avoided, not necessarily for the exam, but for some types of balun also allow an impedance change, which is helpful with some types of HF antenna. A dipole in typical domestic use has a feed impedance close to 50 ohms, so no impedance change is required. The balun may be described as a 1-to-1 balun, and there are 4-to-1 and 9-to-1 baluns for use with other antennas. This is covered by the intermediate and full license courses. Dummy loads. A dummy load is a carefully constructed resistor capable of absorbing all the power from the transmitter. It presents a good matching and no power is reflected. It must also be well screened to minimize any unwanted radiation. This allows the transmitter to be set up and tested without radiating any significant power. Here is a picture of a dummy load. Propagation. That will be covered in our next section. 7.3, all the best. Thanks for watching.